Okay, so I'm going to be solving problem 5.1, I think, which is also 8.3b in the book, maybe. Um, so we are asked to find the um, free response and the time constant of this function here. Um, so since we're trying to find the free response, um, we essentially want to set the left side equal to 0. So I'm going to rewrite this 12x dot plus 5x equals 0. This stays the same. Um, so then we need to take the Laplace transformation. Um, so the Laplace transformation of 12x dot is 12 times s xs, and then we have to subtract the x, x0. So that's minus 3, and then plus 5xs. That's all equal to 0. Now our goal is to get to isolate the x of s terms. So I'm going to factor this 12 through. So that gives me 12 sx minus 36 plus 5xs equals 0. And then I'm going to factor out the xs. So xs times 12s from over here, and plus 5. I'm going to go ahead and add this 36 to the other side. So that equals 36. And then xs equals 36 divided by 12s plus 5. This is an s and this is a 5. They look the same, but maybe I'll put a dash through the s. Okay, so now we have to essentially get this back into the x domain, out of the s domain, back into the x domain. Or sorry, out of the s domain and back into the t domain. I think we're doing x for this. This problem has x. Sorry about that. So what we need to do here is we're looking, the form that we want from that Laplace transformation table is 1 over s minus a, and that is equal to e to the a t. So yeah, basically what we need to do is manipulate this part of the equation to look like that. So the first thing I'm going to do is factor out 12 out of that. So xs equals, what is that, 3 on top divided by s plus 5 over 12. Okay, so now we need to get a 1 on top, and we have a 3 on top currently. So xs equals 3 times 1 over s plus 5 over 12. So right now, this is in this form. So the a here, a equals negative 5 over 12. It's negative because we have a minus here and a plus there. So now we can convert this equation here into this form. So slide that up a little bit. So we have xs equals 3. This drops down 3 times e to the negative 5 over 12 t. Oh, sorry. I need to. This changes back to x of t. So it is the time domain, sorry. So x of t is 3 times e to the negative 5 over 12t. And this right here is the free response. And now we need to find tau, which is the time constant. So tau is equal to m over c, which I'm not actually sure how this applies in this situation because we don't have any m's or c's. But I know that we want it in our end form needs to be something like e to the negative t over tau. So to do this, what we need to do is set tau equal to 12 over 5. So if we set tau equals 12 over 5, then when we plug tau back into this equation, we have x of t equals 3 e to the, what would this be, to the negative t over tau, which is the form that we want. I guess then we can use this 12 as our m and 5 as our c. I'm not 100% sure about that, but this is the correct value for tau. And I think this has units of seconds. So tau is 12 over 5 seconds. And here is our free response.